Hello, this is Dr. Lori. Welcome to this video on logistic regression. I'm going to give you just a little tiny taste of logistic regression and understanding what it does so that when you read about it in the literature, you'll know the kinds of things that they're talking about in terms of why they would want to use that technique. First of all, this whole entire mini lesson topic has been about analyzing data that has a dichotomous outcome, and specifically we've been talking about case control studies. We used an example earlier about neural tube defects where we took a look at 189 cases of neural tube defect and 600 controls, and looked back at the exposure of being vitamin deficient and found an odds ratio of 2.7. So those who were vitamin deficient had an odds of 2.7 compared with the controls of those who were not deficient of being a case. So whenever we do a study like that, this specifically has an outcome that is dichotomous, or they're either a case or they're a control. Remember, that's our dependent variable. Having neural tube defect is dependent on whether the mom was vitamin deficient early in the pregnancy, and so this is the independent variable, this is the dependent variable, this is the X, this is the Y. Oops, that doesn't even look like a Y. We'll make it look a little more like a Y, X and Y. So the dependent variable. So I'm trying to bring a few things together that you've learned so far in this lesson. Now, an interesting thing happens whenever we're studying a relationship, an association. Remember, we have all of these different possible reasons that we might be seeing an association. The p-value and the confidence interval will tell us a little bit about whether it was just chance that we got that odds ratio. We do our very best to eliminate as many of the biases as we possibly can. And then when we get down here to confounding, this is where a lot of times it gets interesting. There are a number of different things that we can do to control confounding, but a lot of times we cannot eliminate it altogether. And so we do our very best, and one of the things that we can do is a regression model in order to get rid of, or at least to control for the effects of confounding. Now, no technique is perfect, but logistic regression is that technique that allows us to do that. So basically, we're without logistic regression, we're using a model that says, I think vitamin deficiency has an impact on neural tube defect. But let's say that there are other variables, maybe the mom's age, maybe other factors that could also impact neural tube defects, sometimes environmental, sometimes genetic. And we would also like to adjust for those other variables so that we can see what part of the whole the vitamin deficiency actually plays. So what we do is we say, okay, well, we're testing whether vitamin deficiency has some kind of an effect on neural tube defects. But let's go ahead and add in some other variables, maybe age and genetics and some other things that we know of, and either correct for or adjust for those as well. And so we end up putting all of those variables into the model together. You can think of it as a great big giant bin or bucket, and collectively together they're all inside and they're all having an impact together on whether neural tube defects occurs. That's what logistic regression allows us to do. And so we had to measure whether a woman took multivitamins during pregnancy or not, and then we had to measure all these other variables, and then we put them magically into this logistic regression analysis and see the effect of all of those variables collectively together. So essentially, when somebody reports an odds ratio, they're telling you, I am only looking at one predictor variable on the outcome variable. But as soon as we say we have an adjusted odds ratio, we use logistic regression to calculate an adjusted odds ratio, what that means is I took that variable that I'm interested in, vitamin deficiency, but then I also was able to add other variables to the model. And sometimes we do that and determine which ones we want to keep and which ones we don't want to keep in the model. Sometimes we put them in the model because we've decided ahead of time a priori that they're important predictors, whether they're statistically significant or not. But once we get done with that, this odds ratio turns in to some adjusted odds ratio, and sometimes that odds ratio will go down or possibly up. It changes the odds ratio so that we can see the effect of that one variable by itself once we've taken out the effect of some other variable or variables that were added to the logistic regression model. So watch for the words logistic regression, watch for adjusted odds ratio as you're reading through the scientific literature, and really they're doing an odds ratio, but they're throwing in some other variables to the model so that collectively together they're all having an impact on that outcome variable. So that is a short summary description of logistic regression.